So here's the promised second part of the lecture, entitled More on Nutrient Upwelling in the South China Sea. Okay, so the contents are, we have a look at the seasonal cycle of plankton blooms in the South China Sea. Let us talk about ammonification. I introduce you to ammonification, what that is. And then we talk about downwelling and extreme bedsheet stresses. Sounds fascinating, doesn't it? So the South China Sea, you learned before that it has a very high fish production, extremely high, almost as high as the total fish production in the Peru-Chile upwelling system, which is also extremely high. Okay, so what are the features in this system in terms of the winds? So the South China Sea is an area that experiences the monsoon winds, seasonal variations, which are illustrated in these maps next to me. Here you have a summer monsoon, this southwest monsoon, and you have a northeast monsoon during winter time. You have a reversal of the. So you expect, in terms of the classical wind-driven Ekman, the Ekman-driven upwelling process, it happens on the left side with respect to the wind direction. Okay, and this is illustrated here. The red areas here. This is where you expect upwelling to. And let's have a look at the summer system. Okay, in the summer, during summertime, and I showed this before in the previous lecture, and this is fluorescence line height. Okay, fluorescence line height is an alternative method. It's a satellite product which is devoid of influences from sediments. It's a little bit better. It's not calibrated everywhere or so, but anyway, in any case, it is more robust in regions where you have a strong bias from sediment, or where you expect a strong bias. Okay, so this is the summer monsoon, and the wind directions are shown here by these white arrows. Okay, and this, let me activate the laser. This is the laser. Wind directions. Okay, northern hemisphere, you would expect an offshore Ekman transport here along the coast of Vietnam and along the coast of China. In this region, it's a little bit more complicated than that. You actually don't necessarily have the winds, but you actually have currents that on their own, they spread or flow along the coast, produce an Ekman layer, a bottom Ekman layer that leads to up. It's a so-called current-driven upwelling. But anyway, okay, you have the Arafura sea upwelling. Okay, this is shown here. This is the one that we just discussed before. Okay, and then you have the Java upwelling and Sumatra upwelling, which form part of the Indian Ocean dipole. There's also some other little upwelling system. It's actually not that small, because if you blow it up in terms of dimensions, it is absolutely massive, these systems in horizontal extent. I think each division here is 5 degrees, so the difference is 500 kilometers here between these lines. Okay, so for later on, let's remember that the red regions have a unit of, it's not 5, but it's 0.5 of fluorescence line height unit. You know, here it says 5, but it's times 10 to the minus 1, so it's divided by 10. So you have 0.5 is your maximum reference level that you look at. Okay, on the next side is a big surprise. Okay, now comes the big surprise. What happens during the winter monsoon? You reverse the wind direction. Have a look at. I snip my finger, and let's see what happens. Look at that. Winter monsoon, you still have plankton blooms. Okay, this is a measure of plankton blooms along the coast of Vietnam and along the coast of China. This is a big surprise. You can't explain this. Ekman theory fails to explain this. That's because you don't get upwelling, you get the opposite, downwelling. It's a very surprising feature, and they are not caused by continental runoff. It's not river discharge which causes it, because river discharge is actually low during the winter monsoon. Okay, this is the dry season. So what causes these? Okay, that's a big, nobody knows yet, and there's no publication. Except it's linked to downwelling, and there is some information on what happens during downwelling. And let's try to explain it. Okay, so hang on.